Okay, so the last part of our discussion in terms of ionic bonding focuses in on ionic compounds that contain what are known as polyatomic ions. So essentially, in a polyatomic ion, you have a group of atoms that has obtained an overall charge. Now, the interesting thing about polyatomic ions is that the atoms in a polyatomic ion are held together by covalent bonds. That's why, if you remember back to the discussion we had a little bit earlier in the module, where we were talking about chemical formulas, and we broke the polyatomic ion down into the polyatomic ion part of the chemical formula into atoms. The reason for that is because the atoms in a polyatomic ion are held together by covalent bonds. But since there is an overall charge, it's an ion, okay? It's not neutral. There's an overall charge associated with it. So it's an ion. The most common element that you see in your polyatomic ions is oxygen. Oxygen is present in so many polyatomic ions. Basically, you have nonmetals, oxygen being the main one, along with phosphorus, sulfur, carbon, nitrogen, and oxygen. And the main thing, one of the other things about polyatomic ions in general is that polyatomic ions usually have a negative charge associated with them. -1, -2, -3. There are some examples of polyatomic ions that have a positive charge, but they are really few and far between. For the most part, your polyatomic ions have a negative charge associated with them. Okay, so here's a chart of the polyatomic ions. You don't have to memorize this, okay? For the midterm exam, I would expect you to bring a copy of this with you. What I do want to mention is probably some of the more common ones that you come across. Now, notice here that all of them have a negative charge, except for ammonium, NH4+, okay? That is one of the few. The other one that we'll see a little bit later on, or if you go on and take Chem 1120, you'll see this one also, is what is known as the hydronium ion, which is really the form of a proton in water. So that's the other main one, H3O with a positive charge. So what are some of the key ones that you come across? Nitrite, NO2-, nitrate, NO3-. What else on here? Hydroxide, OH-, I would definitely say. Then under the -2 charges, sulfite, SO3-2, sulfate, SO4-2, carbonate, CO3-2. And then under the -3 charge, phosphate, PO4-3. I would say that those are probably the ones that you come across most common. And it's a little tricky in a sense because for some of them, their names are very similar. Nitrite, not nitrate, sulfite, sulfate, phosphite, phosphate. The difference when you have those scenarios is essentially you have a 1 oxygen difference. The ITE version usually has 1 less oxygen. The ATE version usually has 1 more oxygen if you're comparing one to the other. But again, you don't have to memorize these, but we have to be able to use them. Okay. So where do we find polyatomic ions? We find polyatomic ions as part of ionic compounds. Polyatomic ions do not exist by themselves. They have to exist in a compound because at the end of the day, the sum of the charges has to add up to 0. Now, basically, we are going to follow the rules for naming and writing chemical formulas that we came up with thus far. But there's one key difference that we want to talk about in terms of writing the chemical formula of a polyatomic ion when you have more than one of that polyatomic ion. So for example, let's write the chemical formula for magnesium nitrate. So magnesium, of course, has the chemical symbol of Mg. And we use the periodic table to come up with the charge for magnesium. Because magnesium is in group 2 or 2A, magnesium has a +2 charge associated with it. Now, nitrate, it's not nitride, it's nitrate, we have to recognize the name of nitrate as a polyatomic ion. So we go back and we'll take a look at our reference chart, and nitrate has the chemical formula of NO3 minus. Okay. So again, right now, if you have one of each, one magnesium ion and one nitrate ion, does the overall charge add to zero? And the answer is no. In order to get the overall charge to add to zero, we need another nitrate ion, because now the charge would be +2 here, and you add these two up, the charge would be -2, and that adds up to zero. Now, when you have more than one of a polyatomic ion, you have to put it in parentheses with the number of it that you have as a subscript outside of the parentheses. So the chemical formula for magnesium nitrate would be Mg parentheses NO32. That would be the correct way to write the chemical formula. All right. What you can't do is you can't stick a 2 in front of the NO3 in between there. Absolutely not. And if you think about it, the reason why you need parentheses is because if you wrote something like this, I would interpret that as MgNO32. And you definitely don't have 32 oxygens that are there. Now, if you have one of a polyatomic ion, you don't need the parentheses. Technically you could put it in, and I wouldn't go crazy about that in a sense, but you don't need the parentheses associated with it. But whenever you have more than one of a certain polyatomic ion, you have to put it in parentheses with the number of it that you have, basically either 2 or 3, or maybe even higher in some rare instances, out as a subscript outside of the parentheses. That's the biggest difference in terms of naming as compared to what we've seen so far. All right. So let's give the name of the following compounds. All right. So the first one is CaNO22. Ca is the chemical symbol for calcium. One thing to also consider, calcium is an A group element. So when I'm writing the name here, I do not have to give a Roman numeral indicating the charge. You will see that will change in our next example. But since calcium is an A group element, I don't have to worry about giving the overall charge as a Roman numeral. And then NO2, if I go back and look at that chart, NO2 is the chemical formula for nitrite. And therefore, the name of this compound will be calcium nitrite. Now, how would you get CaNO2 from there? Well, calcium is a +2 ion. Nitrite is a -1. You need 2 of nitrites and 1 calcium in order to get the overall charge to add to 0. So what does that lead you to? It leads you to Ca parentheses NO2, 2. All right. Example B, FePO4. So Fe, of course, is the chemical symbol for iron. Now, iron is a B group element. So essentially, we have to give a Roman numeral indicating the charge. We'll figure that out in a moment. And then PO4, if I go back to that list of polyatomic ions, I find that PO4 has the name of phosphate. So essentially, this is iron something phosphate. Now, how do I figure out the charge of the iron? Well, based on the chemical formula, there's 1 iron ion. I don't know what the charge of it is yet. Let's see if we can write that a little bit better. I don't know what the charge of it is yet. Based on the chemical formula, there's 1 phosphate ion. PO4 is not in parentheses. So basically, it means there's 1 ion of it present. And the charge of phosphate, as given, this is something you just have to look at from the chart and find, or essentially memorize, is -3. So if phosphate has a charge of -3 and there's only 1 iron, how do we get the overall charge to add to 0? The charge of the iron has to be +3. And therefore, this would be what is known as iron 3 phosphate. Iron 3 phosphate. Okay. A couple other examples. Zinc sulfate. Let's come up with the chemical formula. Now, zinc is a B group element, but it's one of those that only form 1 ion. So you have to sort of remember its charge. And the charge of zinc is essentially always +2. Sulfate, we look at the list of polyatomic ions, and when we come across sulfate, we come across SO4 minus 2. So right now, if you have one of each, does the overall charge add to 0? And the answer is actually yes. Plus 2 and minus 2 adds to 0. So the formula for zinc sulfate would be ZnSO4. And notice no parentheses around the SO4 because there's one of it that's present. Next example, tin 4 carbonate. So tin has the chemical symbol of Sn. It is a B group metal whose charge can form different ions. So the charge is given as +4. And remember, I know the charge is positive because it's a metal. Carbonate, when I look up carbonate on the list of polyatomic ions, I come across CO3 minus 2. So right now, if you have one of each, does the overall charge add to 0? And the answer is no. I have a +4 and a -2. In order to get the overall charge to add to 0, I need another carbonate ion. Because now I have +4 and I have -4. Now the overall charge adds to 0. So what do I have? I have Sn parentheses CO3 2. And notice that I put the CO3 in parentheses because there's more than one of it. There's 2 of them here in this example. All right. And then one more, BaOH2, let's name this. Ba is the chemical symbol for barium. Okay. So again, it's an A group element, so we don't have to write its name. So we don't have to write the Roman numeral giving the charge and the name. And then if we take a look at OH in the list of polyatomic ions, we find that OH is what is known as hydroxide. So the name of this compound would be barium hydroxide. And again, how do we end up with BaOH2? Barium in group 2A forms a -2 ion. Hydroxide is OH minus. In order to get the overall charge to add to 0, I need 1 barium ion and 2 hydroxide ions. And that would lead you to BaOH2.